prelim. Okay. So if I was to evaluate, when you're evaluating piecewise functions, what's going to happen? You look at what interval it pertains to. So I have interval 1, interval 2. So f of -2, which interval does it fall between? Interval 1 or interval 2? Interval 1. F of 0, which interval does it fall between? Interval 2. F of 2, what interval does it fall in between? 2. So that's where you're going to evaluate it from. So f of -2 equals, I plug in -2 into interval, into interval 1. So we have 1 minus -2 gives us 3. F of 0 is going to go in interval 2, and anything times 0 is 0. And then f of 2 goes into interval 2, and a half of 2 is 1. So those would be the values. So first you identify what interval you're using, and then you just plug in and evaluate. How do you feel about evaluating using piecewise? Doable? Not doable? All right. Graphing. So remember how we had that page that went over your choices of how to graph? The how to graph linear, you have 3 options. You can plot points, x and y intercept, or slope intercept form. Okay? We're going to practice slope intercept form. So if I was to graph here, notice that my slope is 1, my intercept is at 1. My slope is -1, and my intercept is at +1. Now the thing here is I'm only making this graph from -3 to 0. So starting at -3, this is what I call a break point, a breaking point. I'm starting at -3, but I'm ending at 0. So if I plug in -3 to this, what do I get? I get 4. -3 times -1 is +3, and 1 plus 3 is 4. So I'm starting here, and from here, I'm going to use my slope to get to 0. And my slope is what? So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. Am I at 0? Yes, at 0. Is it an open or closed circle? Open, because it's strictly less than. At 3, it's closed because it's less than or equal to. So I'm going to make this a open circle, and I'm going to connect my dots. That's the first half of my piecewise. Okay? My second piece of my piecewise, it starts at 0 and ends at 3. So I'm going to plug in 0, and 1/2 times 0 is 0. And is it an open or closed circle at 0? Closed, because it's less than or equal to. Do we see that? So it's going to be a closed circle at 0, 0. And then from there, I'm going to use my slope to make my way to 3. And what is my slope? 1/2. So that means I'm going to rise 1, run 2. Rise 1, run 2. Rise 1, run 2. And this point is just a point to let me know that's where I'm going to go, but I'm actually stopping at 3. And at 3, it's going to be, and then I'm like drawing this so perfect. I'm trying to get to 3 to 1/2. There, I'm there. As good as it's going to get. And that's the other piece of my piecewise. So now that I have graphed it visually, is this a continuous function? Was my preliminary right or wrong? It is not. Because what happens right here? Did these overlap? No, I have a jump in the function. This is a discontinuous function. There is a discontinuity. Okay, we have 3 types of discontinuities. We have gaps, holes, and asymptotes. These are our three types of discontinuities. Okay, this is a gap in my function, so therefore this is discontinuous. And I'm pretty sure that's a word. Because if you can discontinue something, you know, discontinuous has to be a word. It is. I'm pretty sure. Pretty positive. All right, so do we understand why it's not continuous? So you have gaps, holes, and asymptotes. That's what causes your graph to have issues. And we have a gap, so we're not continuous. Questions, comments, or concerns? How did I get the 4? What do you mean the 4? On here, I plugged it in. -1 times -3 is +3, and 1 plus 3 is 4. Any questions about piecewise with linears? It ties a lot of things together. It ties our inequalities, it ties our linear graphing, and it ties our understanding inequalities. It would have been continuous if they overlapped. So where I had that open circle, if my closed circle had came and filled it in, then it would be continuous. Like if the graph was 1/2 x plus 1, like if this had been 1/2 x plus 1, then these would have overlapped and it would be continuous. But because there's a gap in the function, it makes it discontinuous. Your 3 signs of discontinuity are gaps, holes, and asymptotes. But because they did not meet, that it is discontinuous. Like our word problem yesterday, if we were to graph these, they would end up overlapping. And so where the hole would be, the next one would fill it in. Because it's a continuous situation. It's going from one point to the other point to the next point. But this one, it's not continuous because those values didn't overlap. Let me see. Like if this function was 1/2 x plus 1, the graph would have started here and ended like this. Then it would have been continuous because there wouldn't be that gap. But this is not what we were graphing. We were graphing this guy. Does that clarify? Okay. Sorry, may you close the door, please? All right, variations. So we have direct and inverse variation. Our linear equations are an example of direct variation, okay? Y varies directly as x. So what that means, as you're reading it, is that basically there's a constant that is that you multiply by to get your linear equation. So direct variation is just your b equals 0. That's the main thing, is your b will equal 0. All you're focused on is and when that happens, it's called constant k, but you're just looking on b equals 0. Inverse variation, y varies inversely with x, and that's division. And so your constant is what your numerator is. But we're focused on this section, direct variation. So here we have this problem. A 15-pound weight is hung on a spring and it stretches 5 inches. Find the spring's constant, okay? So if I'm looking for the spring's constant, I have a 15-pound weight and it's stretching. Think about physics, force equals K times X. So in this case, our force is 15, right? And it's going to equal our K times our inches, which is 5. So what would K have to be? What is my spring constant? 3. K would equal 3. This is tying into El Físico. Okay, so physics, K times X. Does that sound at all vaguely familiar if you've taken physics before? I hope so. I would be really concerned if y'all left physics not knowing this. It'll hurt my heart. Okay, so now you know your K. So your K equals 3. So now that you know K, you now have a function. So you have f of X equals 3K. Meant 3X. 3, where's my eraser? There it is. 3X, my bad. Your weight is your force, and force is dependent on, this is your force, which is dependent. So it's dependent on time, it's dependent on the what? Yes, in reality, but for the, how can I say it? No, for the context of physics. I'm trying to think of it as a physics teacher. This is legit a physics problem. What is the reason? I'll ask Mr. Huffman and get him clarification as to why the weight is the force is dependent. Yeah. So like the spring itself is the independent, and then the force of it is what pulls it down. Is how I'm understanding it. But as far as physics go, I'm going to tell y'all right now, I can do the math behind it. The explanation, I'm not your girl, but I'll find it for you. So we did the math, found our K, determined how far the spring will stretch when 32-pound weight is hung on it. Now your force is what? Your force equals 32, and you want to know how many inches it's going to stretch. So I have 32 equals 3x. So therefore, divide by 3, and that's going to give me x is approximately 10 7/10 inches. So again, there's my spring. Here's my weight on it. And I get what you're saying 100%, Zane, about how the weight should be the determining factor of what's happening to the spring. But in physics, the stretching of the spring, this is your independent. And I promise you, I will get it for you. I will ask Mr. Huffman. I'm human enough to say, I just remember learning in physics that the force is the dependent and the stretch is the independent. And that's all I ran with it. I didn't question it. You're a good student for questioning it. All right, so here we have just practicing with varying directly. So in this situation, it's telling us that y equals 23 and x equals 7. And we are doing direct variation because it says y varies directly. So we have y equals k times x. And I know this because it tells me right here, y varies directly with x. Agreed? Okay. And it says, suppose that y equals 23 and x equals 7. So step 1 is I'm going to use my given information to solve for k. So it told me that y is 23 and x is 7. So therefore, k equals, I'm just going to leave it as a fraction, 23 over 7. I don't like mixed numbers. You can use it as a mixed number. And then 2, I'm going to substitute that value in. And that's going to give me now y equals 23 over 7 times x. And then 3, solve the unknown. And what is my unknown right now? Y. So when I solve, I now have y equals 23 over 7 times 11. And therefore, y equals 253 over 7. How do we feel about direct variation? Just straightforward. Good? 3 steps. Solve for the k, substitute the value in, solve the unknown. Solve for the k, substitute the value in, solve the unknown. Easy enough? All right. Here is a word problem for direct variation. It wants us to compute the direct variation for all 4 points. So just like when we did with the slope, we have to find the direct variation for each one. So from one point to the next. It's a little different though, because all you're doing is setting up ratios. So if we think about y equals k times x, right? If we want to solve for k, we would divide by x, agreed? So therefore, the k equals y divided by x. Do we see that correlation? So if I'm looking for the ratios for each one of these, I'm looking for their k. I'm looking for k1, k2, k3, and k4. And I want to compare them. Are you with me? Feeling okay? Yeah? Okay. So to find k1, it's going to be 6 and 1/10 divided by 1300. And you're going to give me an approximate value. Find k2, it's going to be 19 and 7/10 divided by 4200. Get an approximate value. To find k3, it's going to equal 48 and 4/10 divided by 1 and 300. Gives me an approximate value. And to find k4, it's going to equal 54 and 5/10 divided by 1 and 1600. And it's going to give me an approximate value. And I want to see, I know that it varies directly if the k values all are similar or round to the similar amount. So if I put 6 and 1/10, I'm going to get about 6 and 9/10. 46 and 9/10. I plug in this, I get about 46 and 9/10. I get 47 and I get 47. So analyzing these numbers, are they all approximately the same value? Yes, they are. They are all approximately the same value. So therefore my k equals about 47. How do you feel about computing the k given a table? Was it terrible? Can we all divide? That's the question. All right. So now that we know what k is, we can write our direct variation equation. So y equals 47 times x. So it says I have 5 megabytes and it wants to know how many seconds. So it's giving me my x, and I need to find my y. So step 1 is to solve for k. Step 2 is to substitute it in, and step 3 is to find your unknown. So I have y equals 47 times 5, and I get 235. So we know y equals 235 seconds. So if the song is 5 megabytes long, it's going to take 235 seconds. I mean, if I have 5 megabytes of storage, I have 235 seconds of song I can store. Okay, calculator. You can graph this in the calculator once you have your K, and look at the line and answer any questions. I don't think I really need to go over how to graph this in the calculator. So in the calculator, you go to Y1 and you type in 47x. You can look at the table, you can evaluate. Oh, that is what I wanted to show you. I lied. I did want to show you on the calculator. So on the calculator, some good things to know. If I type in 47x, I go to graph. If there is a specific value that I want, I hit second, trace, and you see where it says value? You press 1 and you type in that value. So if I want to know 5, is it not showing? It is not showing. New share. Y'all are just going to let me keep typing? Now you see it? Because I was looking at the screen too and I wasn't paying attention to it. So let's try that again. So I went to y equals. I typed in my equation. I went to graph, let it graph, and then I'm going to go second, trace, and if I'm looking for a specific value, I'm going to click where it says value. If I'm looking for 5, I type in 5, and it's going to say, oh, that's 235. If I was looking for 4.5, so second, trace, value, I'm looking for 4.5, and it's going to tell me, here's your 4.5. If I'm looking for a fraction, so second, trace, value, let's say I'm looking for 4 1/3. I'm going to put in 4 plus 1/3. Hit enter, and it's going to say, here's your value. Okay, that's utilizing the calculator. How do we feel about being able to utilize the calculator? Easy breezy? Any hesitations about it? Okay. Well, back to our presentation. Look at that smooth transition. All right. That concludes the rest of your, what's that thing called?